Good morning. Intercepts. So we have used the term Y-intercept in case of equation of straight line y is equal to mx plus c. And we have given a small introduction about Y-intercept in that class. So let's discuss more detailed about intercepts. Let us consider a coordinate system with x-axis, y-axis and a straight line. And when you check this straight line, see this straight line cuts y-axis at a point. Yes, so that a distance is formed from origin to that point. So see, what is this distance? It's the distance from origin to a point on y-axis formed by the intersection of straight line. This distance on y-axis is called Y-intercept that we discussed already. Similarly, the straight line meets x-axis at a point, so that distance from origin to that point on x-axis, this distance is called as X intercept. Okay, in every equation of straight line we can find out the x-intercept and y-intercept easily. Let's see how to find out that. This is a very simple topic. Question: find the x and y intercepts of y is equal to minus 5x plus 10. So we have to find the x intercept and y intercept. Okay, let's see what to do here. We are going to find y intercept first. Okay, y intercept, even directly we can identify what is y intercept here, because this is in the form of y equals mx plus c, where c is the y-intercept. In the place of c we have 10 here, so y-intercept is 10. This is one method. With the help of a graph, how to find intercepts we'll discuss now. Look at this point. When you look at this point, this is a point on y-axis. What is it? It is a point on y-axis, and we know a point on y-axis makes x value 0. On y-axis there is no value for x, so x is 0 and a certain y coordinate. So on y-intercept, so we can interpret it as on y coordinate. That means on y-intercept the x value is 0, or to find y-intercept put x is equal to 0. So to find y-intercept, what we do? Put x is equal to 0. Very simple. Just substitute x is equal to 0. We get y is equal to, when x is 0, this whole term becomes 0. So we get the remaining answer as 10. So we get y-intercept is 10. Similarly, to find x-intercept, you know, on x-axis there is no value for y, so that the value of y is 0. On x-axis y coordinate is 0, and on y-axis x coordinate is 0. So to find x-intercept, what shall we do? Put y is equal to 0. So we get the equation become 0 is equal to minus 5x plus 10. That implies when you take plus 10 to the other side, we get it as minus 10. That is minus 5x is equal to minus 10, or else take minus 5x this side. That's also okay. So that x is equal to minus 10 divided by minus 5. When you cancel the terms, we get the answer as 2. So x-intercept is 2 and y-intercept is 10. So y is equal to 2x by 5 plus 1. So to here find y-intercept and x-intercept is the question. So to find y-intercept, if you want to find y-intercept, what do we do? To find y-intercept, put x is equal to 0. So when you put x is equal to 0, we get y is equal to 2 times 0. 0 by 5, 0. This term becomes 0 plus 1. So y is equal to 1. So y-intercept is 1. Now to find x-intercept, put y is equal to 0. So when you substitute y is equal to 0 in the equation, we get 2x by 5 plus 1 is equal to 0. That become 2x by 5 is equal to minus 1. Take plus 1 to right side. That implies 2x is equal to, cross multiply, we get minus 5. That implies x is equal to minus 5 divided by 2 as x-intercept. We have another question, y is equal to 3x plus c, in which the line passes through a point 1, 5. This line passes through a point 1, 5. Find the value of c. That means find y-intercept. Okay. For that, what shall we do is, the point is 1, 5. That stands for x is 1 and y is 5. So when you replace x and y here, we get 5 is equal to 3 times x, 1 plus c. So we get 5 is equal to 3 plus c, or when you transpose 3 to here, we get c is 5 minus 3. That's equal to 2. So that we get the y-intercept c as 2. Next topic is to find the length of a line segment. You know, by using a ruler, we can find the length of a line segment easily. But that comes in plane geometry. When we discuss the length of a line segment in coordinate geometry, here we cannot use any instruments for measurement. But we have to find the length of a line segment accurately. So in such case, we use certain formulae. So to find the length of a line segment, we use a formula which is the length of the line segment AB is equal to, under the root, x2 minus x1 the whole square plus y2 minus y1 the whole square. So the length of a line segment can be found by using the formula x2 minus x1 the whole squared plus y2 minus y1 the whole squared should be in root. Okay, that means it's very simple. Root of change of x square plus change of y square. Change of x squared plus change of y squared. Okay, so when you do a problem, you'll have come to know this one in detail. Suppose you want to find the length of this line segment A34 and B710. These are the two end points. One point is A34 and the other one is B710. So when you consider these points, here x1 is 3, y1 is 4. Similarly, x2 is 7 and y2 is 10. And as per the formula, length of a line segment AB is root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to under the root x2 minus x1. You know, x2 minus x1 means a change of x. x2 is 7 and x1 is 3. That means x2 minus x1 is 7 minus 3 the whole square plus y2 minus y1 the whole square, that is 10 minus 4 the whole square. See, the work is very simple, but we need to remember the formula, which is equal to under the root 4 squared plus 6 squared, that is equal to square root of 16 plus 36. That's equal to under the root 16 plus 36 is 52 units. Is the answer of length AB. Let's find the length of the line segment P minus 2 minus 7 and Q 7 minus 10. Okay, so P minus 2 minus 7 is in quadrant 3 and this is in quadrant 4. That doesn't matter here, but I am showing the line comes like this between quadrant 3 and quadrant 4. Now to find the length of this line segment, we must know x1. So this is x1, this is y1, x2, y2. It's your wish what you be taken as x1 y1 and x2 y2. Okay, same like gradient. Remember the formula for gradient, change of y by increase of x, y2 minus y1 by x2 minus x1. So when it comes the length of a line segment, it is under the root x2 minus x1 the whole square plus y2 minus y1 the whole square. That's equal to square root of x2 minus x1, x2 minus x1, x2 7 minus x1, x1 is minus 2 squared plus y2. What is y2? Is minus 10 minus y1. y1 is minus 7 the whole square. It's very simple now, which is equal to under the root 7 minus into minus is plus, so 7 plus 2 9 squared plus minus 10 minus into minus is plus, so minus 10 plus 7 is minus 3 squared. That's equal to square root of 81 plus minus 3 squared is 9. So we get it as square root of 90 units as answer. Okay, in the next class we'll discuss about the midpoint of a line segment and more problems about parallel and perpendicular lines. Thank you.